Hello, Geometry International Honor students. Welcome to our 3.1 and 3.2 notes. So let's dive in and start with some vocabulary. Some you'll already know. We've already talked about parallel lines. Let's define those lines. Now, parallel lines, a symbol we use to indicate that two lines are parallel would be these two side-by-side parallel segments. They kind of look like skis. But that's the symbol we use, and that symbol means is parallel to, so it's a lot quicker than writing all those words. But we define parallel lines like this. We say parallel lines are lines that are coplanar. They lie in the same plane, but they do not intersect. So think like railroad tracks would be a good example of parallel lines. Skew lines, now we've talked about these in class. Skew lines are lines that are not coplanar. So they do not lie in the same plane, and they also do not intersect. We'll look at some examples of skew lines in just a minute. But let's first define parallel planes. Parallel planes like the floor and the ceiling of the room that you're sitting in. Parallel planes would be two planes that do not intersect, have no points in common. Okay, so let's look at some examples. And before we do, we need to notice that this note. We're going to use this diagram. We need to assume that any segments that appear to be parallel, we're going to go ahead and assume that they are parallel, and any intersecting segments that appear to be perpendicular, we will assume that they're perpendicular as well. So let's start with our first example, segment AD and segment BC. Well, I think you can see that they lie in the same plane. If you can imagine this plane that would be like the front of a box, of a rectangular prism, they lie in the same plane. They do not intersect. So we would say that those lines are parallel. All right. And then number 2, segment EF. Let's see, segment EF and segment DH. Okay, so those segments do not lie in the same plane, and they will never intersect. So that would be an example of two segments that are skewed to each other. They do not lie in the same plane, and they do not intersect. Number 3, we're going to take a look at segment BC. Let's see, segment BC, that's this one, and segment CG. Well, we can tell, even before I highlighted them, I knew that they were going to be intersecting because notice they both have C in the name. They both share that point C. So we would say that those 2 points are intersecting, and you could even go further and say that they're perpendicular, because remember, we assumed that any segments that appear to be perpendicular were perpendicular. Okay, number 4, we're going to look at a couple of planes. So let's start with plane ABC. So that would be, if you can imagine, the front of this rectangular prism. Okay, the front of that box. Okay. So a plane that would be parallel to that one would be the back of the box. So this segment back, or that plane back there. Now remember, when we name a plane, we can name any 3 points. So I'm just going to use AEF, and we're going to call this plane plane AEF. There are many other correct names for that plane. Okay, then let's take a look at number 5. Okay, number 5 says, let's see, segment AD, that is the segment AD, and name a line that would be skewed to AD. Now, there are many correct answers. So, for example, HG, there's an example of a segment that does not lie in the same plane and would never intersect. Another one would be EF, okay? Couple more skewed segments would be, let me change colors, BF and CG. Now those are parallel to each other, but they're both skewed to the yellow. So many correct answers, so I'm just going to pick one of those. I think I'll pick the first one we named, which was segment EF. All right, and then number 6 says, let's see, segment AE. So that would be this one, segment AE and blank are parallel. So many correct answers. BF would be a correct answer. DH would be a correct answer. And then, if you can imagine a plane that slices diagonally through this box or through this prism, you can see that AE and CG would also be parallel. So any of those that we've mentioned would be correct. I'm just going to pick one. How about the first one we named, which was segment BF? Many correct answers there. All right, and then number 7 says segment DC which is this segment, segment DC, and blank are perpendicular. So it says many right answers, but there's really just a couple of them. That would be AD and BC would be two segments that would be perpendicular to segment DC. So I'm going to go ahead and just name the first one AD. And then last but not least, EF and DC. Let's see, what would their relationship be? So EF is here. Oops, I'm going to make that a highlighter. Hold on just a second. EF is this segment, and then segment DC. Again, if you can imagine a plane that's slicing diagonally through this prism, you can see that those two yellow segments lie in the same plane but never intersect. So we would say that they are parallel. Parallel. All right, so now let's move on and talk about a new term you may not have seen before, and that's called a transversal. So a transversal, first of all, is a line. It's a line that intersects two different lines in two different places. So, for example, we have line T. Notice that line T, I'm going to highlight it in yellow. It intersects two different lines, line R, which I'm going to highlight in blue, and line S that I'm going to highlight in green. So you can see that line T, the yellow line, intersects two different lines in two different places, so we call that a transversal. And obviously when you have a line that's intersecting two different lines, there are going to be a whole bunch of angles that are formed, and what we're going to be interested in are some angle pairs that are formed by a transversal that's intersecting two separate lines, two different lines. So the first angle pair we're going to talk about are what are called corresponding angles. So corresponding angles lie on the same side of the transversal and on the same sides of R and S. So an example of a pair of corresponding angles would be angle 1 and angle 5. Notice that 1 and 5 lie on the same side of the transversal. They're on the left side of the transversal, and they're also above the two lines being transverse. So 1 is above the blue line and 5 is above the green line. Another way to look at that is you can see how there's a little group of 4 angles here and another group of 4 angles here. You can see that 1 and 5 occupy corresponding positions in their relative groups of 4. So we'll go ahead and list angle 1 and angle 5 is our first pair of corresponding angles. Okay, so another pair of corresponding angles would be, let's see, how about angle 2 and angle 6? Again, notice they're on the same side of the transversal and they're above the two lines being transversed, or in other words, they occupy corresponding positions in their little group of 4 angles. Another pair of corresponding angles would be angle 3 and angle 7. Same side of the transversal, and both of them are below the two lines being transversed. So we'll say angle 3 and angle 7, and then there's not quite room to write one more, but there is one more pair of corresponding angles, and that would be angle 4 and angle 8, the ones I haven't circled. Again, they're both in the, if you think of these two little groups of 4 angles, they occupy corresponding positions because they're both to the right of the yellow transversal, and they're both below the lines being transversed. So angle 4 and angle 8. So we'll add that to the list. And angle 8. Okay, so the next pair of angle pairs we're going to talk about are alternate interior angles. So alternate interior angles, okay, the definition says that alternate interior angles are non-adjacent angles, that's important, that lie on opposite sides of the transversal T and between the lines R and S. Now, between means they lie on the interior. So let me just highlight real quick the interior of the two lines being transversed. So this region would be the interior of the two lines being transversed, and then above line R would be an exterior, above, and then below line S would be the exterior. So if you look at our angle pairs, angle 3 and 6. Notice they are non-adjacent, okay? They're on alternating sides of the transversal, and they're on the interior. They're in the yellow region. They're the interior of the two lines being transversed. So we're going to have two pairs of alternate interior angles. One of them would be angle 3 and angle 6, and then the other pair would be angle 4 and angle 5. Again, notice they're on alternating sides of the transversal. They're non-adjacent, not like 5 and 6 or 3 and 4, but non-adjacent on opposite sides of the transversal and on the interior of the two lines being transversed. So that's angle 4 and angle 5. Okay, next we're going to talk about alternate exterior angles. So alternate exterior angles they lie on opposite sides of the transversal T and outside or on the exterior of the lines R and S. So for example, if you look at angle 1 and angle 8, notice how they are on alternating or on opposite sides of the transversal, and they're in the blue region. They're on the exterior of the two lines being transversed. So that's our first pair of alternate exterior angles. That's angle 1 and angle 8. And then if you look at 2 and 7, I'll just highlight those in green, I guess. 2 and 7, notice that they are on alternating sides of the transversal and in the exterior of the two lines being transversed. So 2 and 7 would be our other pair of, angle 2 and angle 7 is our other pair of alternate exterior angles. Okay, so the next angle pair we're going to talk about are same side interior angles. Sometimes you'll see those called consecutive angles. So let's just make a note, AKA, also known as, also known as, also known as consecutive angles. And I'll talk about why in just a second, why we call those consecutive angles. So alternate exterior angles lie on the same side of the transversal and between lines R and S. Oh, I guess I already noted that they're also called consecutive interior angles. So let me erase this a little bit. Let's find a pair of angles that lie on the same side of the transversal and also sorry, I'm having some technical difficulties. Okay, same side of the transversal, but they also lie in the interior of the two lines. So for example, look at angle 3 and angle 5. They lie on the same side of transversal T, but they're in the interior. So angle 3 and angle 5 would be our first pair of same side interior or consecutive interior angles. And the second pair would be angle 4 and angle 6. Again, they lie on the same side of the transversal, and they're on the interior of the two lines being transverse. So angle 4 and angle 6. So let me just make a quick comment. The reason why we call these consecutive interior angles is later we'll be talking about some shapes, like for example parallelograms. So let's take a look at this parallelogram. I'm going to call it A, B, C, D. And if you look at angle A and angle B, I'm going to highlight angle A in yellow and angle B in red, okay? Notice they are on, now this is a parallelogram, okay? So you can think of this side of the transversal, this side of the parallelogram as a transversal. So you'll see that they're lying on the same side of the transversal on the interior of these two lines being transversed. So they're same side interior. In terms of the parallelogram, we would call AB, we would call them consecutive. That means right next to each other or right in a row. So AB would be a pair of consecutive interior angles. So let's take a look at this example that says use the diagram at the right to name the transversal. Remember, a transversal is a line that touches two different lines, and then identify the angle pair. So our first angle pair we're going to look at are angle 2 and angle 7. So let me just mark those, angle 2 and angle 7. So first of all, we need to find the transversal that created those two angles, the line that touches two other lines to create those. Well, that would be this line C. So let me highlight that line. I'm going to highlight it in yellow. Okay, so C is our transversal. So we'll mark that down. So C is the transversal, and then we need to name the angle pair. So if you look at our angle pair, they're on alternating sides of the transversal, and they're in the interior. Let me shade that interior. Okay, they're in the interior of the two lines being transversed. So we would say that those two angles are alternate interior angles. Now, often we will abbreviate. So I'm going to use ALT for alternate and INT for interior, and then I'll obviously use the angle symbol. So line C is the transversal, and we would call this pair of angles an alternate interior angles. All right, so then let's take a look at the next example, angle 8 and angle 12. So let me indicate those. So here's 8 and here's 12. So first let's find the transversal. Well, the line that touches two other lines or intersects two other lines to form those angles would be this line B. So let me highlight that. So here's line B is our transversal. All right, and so then the angles, notice that the angles are on the same side of the transversal. Okay, they're both below the transversal, and they both appear to be to the right of the two lines being transverse. Or if you look at this group of 4 angles and this group of 4 angles, you'll notice that 8 and 12 appear to occupy corresponding positions. So we call those corresponding angles. We'll abbreviate that CORR period. Those are called corresponding angles. Okay. So the next one, we're going to take a look at angle 9 and angle 3. So let me indicate those. Here's 3 and here's 9. Okay, so first of all, let's find a line that touches two other lines to create those angles. So that line would be this line, line A. Okay, so A is our transversal. Okay, and then what kind of a pair of angles is formed when that transversal touches two other lines? Well, you'll notice that the two angles are on the interior of the two lines being transversed. All this region is the interior, and they're on the same side of the transversal, so we'll call those same side interior. Here's how we'll abbreviate that. SS for same side, so same side interior angles would be what that angle pair is called. And then our last example, let's take a look at angle 1 and angle 11. So here's 1 and here's 11. So first of all, what is the transversal that touches two other lines to create those angles? Well, that would be this, line A. So line A is our transversal. Now, if you look at the two lines, I'm going to shade the interior. Let me shade the interior of those two lines so we can see that angle 1 and 11, they're not in the interior of the two lines being transverse, they're on the exterior, and they're on alternating sides of the transversal, so we would call those alternate exterior angles. So the transversal that formed those angles would be transversal A, line A, and we would call those alternate exterior, or again, we're abbreviating, alternate exterior angles. Okay, so the next thing we're going to do is talk about a postulate and then some theorems that have to do with these angle pairs. So this first postulate we're going to talk about is called the corresponding angles postulate. Now, let's just remember that a postulate is a statement that we accept as true without proof. We couldn't prove it even if we wanted to, because there's nothing to prove it with. But once we state this corresponding angles postulate, then it goes in our toolbox of reasons that can be used in a proof. So we can use this corresponding angles postulate to prove some later theorems that you'll see in a minute. So here's what the corresponding angles postulate says. It says if two parallel lines, now again, you can write the word parallel, or if you want to, you can just use the symbol. So remember that symbol means is parallel to, or just parallel. Okay, so you can write the word or use a symbol. That's important that in the in the hypothesis of this theorem, we're assuming that the two lines that are being cut by a transversal are parallel. So we say if two parallel lines are cut by a transversal, then corresponding angles Corresponding angles are congruent. Okay, so anytime parallel lines are cut by a transversal, corresponding angles are congruent. Now, as I said, we're going to be using this postulate often as reasons and proofs, but it's kind of long, so we don't want to have to write the whole thing out. So we're going to abbreviate this theorem like this. We're going to write the hypothesis. Let me underline the hypothesis once, which is if two parallel lines are cut by a transversal. We're going to abbreviate that all the way down to, we're just going to say parallel lines. Now, we're going to assume, obviously, if we're talking about corresponding angles, a transversal has to be involved. So just writing this shorthand little statement here, what we're really assuming is that we have a pair of parallel lines that are being cut by a transversal. Then the conclusion of that theorem is that corresponding angles are congruent. So we'll abbreviate that conclusion like this. We'll just say CORR for corresponding, and then the symbol for angles, and then the symbol for congruent. So this is a shorthand way to write, when parallel lines are cut by a transversal, we can conclude that corresponding angles are congruent. So let's use that postulate to solve a couple of problems here. You'll notice in this first example that we have a couple of lines, I'm going to mark them in blue, that are parallel. Oh, I don't know if I've mentioned this before, but if I haven't, let me mention it right now. When we're looking at a diagram and we want to indicate that lines are parallel, we put arrows on the lines that we want to indicate are parallel. So anytime you see those arrowheads, you know that we're indicating that the lines are parallel. So in this example, we have parallel lines, the blue lines are parallel, and they are being cut by a transversal. Let me highlight that transversal. So if you'll notice, the 75-degree angle and the 15x degree angle are on the same side of the transversal. They're both, I guess, above or to the right of the transversal and on the same side of the blue lines. So they occupy corresponding positions in their little group of 4 angles. So since we have parallel lines being cut by a transversal, then we can conclude that those angles are congruent. So since they are congruent, let's go ahead and find x. I guess I should have put that in the directions. Let me add that. Let's find the value of x by just taking 15x and setting it equal to 75. We'll divide both sides by 15, and we get x is equal to 5. Okay? In this next example, notice again that we have parallel lines. The reason why we know these blue lines are parallel is because you see these little arrows on the lines. So we're assuming that those lines are parallel. They're being cut by this yellow transversal. So you'll notice that these two angles, the 5x minus 30-degree angle and the 2x plus 60-degree angles, they're on the same side of the transversal and they're above the two blue lines. So they are occupying corresponding positions in their little groups of 4. So we can go ahead and say that this angle is congruent to that angle. When parallel lines are cut by a transversal, corresponding angles are congruent. So we can set 5x minus 30 equal to 2x plus 60, because remember, if two angles are congruent, then their measures are equal. I'm going to subtract 2x from both sides and add 30, and we get x is equal to 30 degrees. X is just equal to 30. Okay, so we have this postulate stated that says anytime parallel lines are cut by a transversal, corresponding angles are congruent. Now the next 3 statements we're going to talk about are theorems, and theorems, of course, are statements that can be proved. So we're going to write down 3 theorems, but we're only going to prove one of them in class today. You'll prove the rest of them in your homework. So the first one is the alternate interior angles theorem. And here's what the alternate interior angles theorem says. If two parallel lines, so that's important, we're assuming that we have lines that are parallel, are cut by a transversal, then two parallel lines cut by a transversal, then the pairs of alternate interior angles are going to be congruent. All right? So here's how we'll write that theorem in shorthand. We're going to say parallel lines and then put an arrow. So what we're assuming, because we're going to talk about alternate interior angles in just a minute, well, alternate interior angles wouldn't exist unless we had a transversal. So this hypothesis, this is a shorthand of writing this whole hypothesis that if two parallel lines are cut by a transversal, Then let's write the conclusion that the pair of alternate interior angles are congruent. Let's write that in shorthand, and we'll write it like this. We will just say alternate, A-L-T, interior, I-N-T, and then use the angle symbol and then the congruent symbol. So our conclusion is alternate interior angles are congruent. So we're going to prove that theorem. So I've got a 2-column proof set up to prove that. Let's write our given and our proof statement in terms of a diagram. So we're going to start with a diagram. So I need you to draw 2 lines. Whoops. Let's draw 2 lines. Now, remember, we were assuming that those lines were parallel. That's in our hypothesis. So go ahead and mark them parallel. So 2 parallel lines, and let's draw a second line that cuts them. That's called, a third line that intersects both of them. That's called a transversal. Let's call the parallel lines, let's call them L and M, and let's call the transversal T. And then I need you to number some angles. If you would number this angle 1, this angle 2, and this angle 3. Okay, so here's what we're going to write for our given statement. Remember, our given statement, we write what we're assuming to be true. So what we're assuming to be true is that we have some parallel lines. Well, in our diagram, the names of those lines are L and M. So we're going to say for our given statement that L is parallel to M. And then the conclusion of our theorem is that alternate interior angles are congruent. So in our diagram, we've numbered this angle 1 and this angle 2. Notice they're on alternating sides of the transversal and the interior of the 2 lines being transversed. So they're alternate interior angles. So we are going to prove that angle 1 is congruent to angle 3. All right. So if you have no idea where to start, it's always a good idea to start with your given statement. So we're going to assume that L is parallel to M. Why is that true? Because we said so. That's why. That's what given means. That means we're going to assume that that's true, that L is parallel to M. Now, we have 2 parallel lines cut by a transversal. At this point, what do we know? There's only one thing we know about parallel lines being cut by a transversal, and that is this postulate, which says when parallel lines are cut by a transversal, corresponding angles are congruent. So if you look at our diagram, we've numbered angles 1 and 2. Notice that they are on the same side of the transversal and below the 2 lines being transversed. So we say that they are corresponding angles. So since we have parallel lines cut by a transversal, then we can go ahead and say that angle 1 is congruent to angle 2, and we justify that with that postulate, the corresponding angles postulate. Now we're going to write it in shorthand, so write this: parallel lines. We're going to assume that we have parallel lines cut by a transversal. We get to conclude that corresponding angles are congruent. Okay. Now, another angle pair that we're familiar with, I want you to take a look at angle 2 and angle 3. When we have non-adjacent angles formed by intersecting lines like this, remember that was a pair of angles called vertical angles. And we proved in our last unit that vertical angles were always congruent. So let's go ahead and say that angle 2 is congruent to angle 3, and we'll justify that with the vertical angles congruence theorem. We proved that in our last unit, so that theorem is now in our toolbox full of reasons that we can pull out for justifications in a proof. Okay, so now I want you to look at where we are. We have angle 1 congruent to angle 2, and angle 2 is congruent to 3. So I have a first angle congruent to a second angle, and that second angle is congruent to the third angle. So because of that, because we have a postulate that says, or not a postulate, I'm sorry, it's a property of congruence that says when we have a first angle congruent to a second and a second is angle congruent to a third, we can conclude that the first is congruent to the third. In other words, I can say that angle 1 is congruent to angle 3 because remember that was the transitive property of congruence. All right, so we have now proved that anytime parallel lines are cut by a transversal, alternate interior angles will always be congruent. Okay, we also have an alternate exterior angles theorem that says the following. It says if two parallel lines are cut by a transversal, then pairs of alternate exterior angles are also congruent. Okay, we will write that in shorthand like this. We'll say parallel lines and then put an arrow. So that implies when parallel lines are cut by a transversal, we can conclude that alternate ALT, exterior EXT angles are congruent. You'll prove that in your homework. You will also prove this theorem, the same side interior angles theorem, which says if two parallel lines are cut by a transversal, then the pairs of same side interior angles are not congruent this time when we have same side interior angles formed by parallel lines cut by a transversal. We say that those same side interior angles are supplementary. You will be proving that in your homework. And this is how we will write it in shorthand. We will say when parallel lines are cut by a transversal, we can conclude that same side interior, SS and then INT, interior angles are not congruent, but they are supplementary. We'll go ahead and abbreviate that SUPP. Okay, if you have any questions over these notes or over your 3.1, 3.2 homework, be sure and ask me in class, and I will see you then.